Hi guys, in this video tutorial we will be discussing about ANOVA and its computations. First of all, it's important to know that ANOVA stands for Analysis of Variance. The outline for this session will start with an introduction, then the different types of ANOVA, the assumptions of ANOVA, the hypotheses in ANOVA, main effects or interaction effects, post hoc tests, and the F distribution. Now here we have the learning outcomes. Students will be able to, first, define ANOVA, second, identify the different types of ANOVA, third, state a hypothesis in ANOVA, fourth, know how to use the F distribution table, and fifth, solve problems involving the use of ANOVA. Now let's begin with the introduction, where we will tackle about what and for what ANOVA is. So what is ANOVA? ANOVA, standing for the Analysis of Variance, is a collection of statistical models and their associated estimation procedures used to analyze differences among group means in a sample. It is a statistical method in which the variation in a set of observations is divided into distinct components. Unlike when we're doing t-tests, we could only compare 2 samples. With ANOVA, we can compare 3 samples, 4 samples, or 7 samples. We can compare more than 2 groups. Like every other idea, ANOVA was developed by Ronald Fisher. To better understand what we're teaching, it's best to know what ANOVA is used for and why it's important. ANOVA is used to compare the means of 2 or more groups, to provide necessary information for decision making, and to confirm whether some improvements or changes in a process are making a difference. ANOVA is important because it is a way to find out if survey or experiment results are significant. It enables us to see, for example, how effective 2 different types of treatment are and how durable they are. Now in ANOVA, you have factors and you have levels. Factors are just your variables. Like in one case, gender can be a factor. And the levels are the levels of those variables. Like gender could have 2 levels, male or female. So like here's an example with 3 groups, 0 milligrams, 50 milligrams, and 100 milligrams. Those are different dosages. So in this case, your factor is dosage, and your dosage factor has 3 levels, 0, 50, and 100 milligrams. So next we have the different types of ANOVA. Now there are a few different types of ANOVA, and we're gonna show you about 3, namely one-way ANOVA, repeated measures ANOVA, and factorial ANOVA. So first we have one-way ANOVA. One-way ANOVA is one factor with at least 2 levels, and the levels are independent. For example, adventurous researchers studying a population of walruses might ask, do our walruses weigh more in early or late mating season? Here, the independent factor is month of mating season. In ANOVA, independent variables are organized in categorical groups. For example, if the researchers looked at walrus weight in December, January, February, and March, there would be 4 months analyzed and therefore 4 groups to the analysis. Another definition of one-way ANOVA is that it is a type of statistical test that compares the variance in the group means within a sample, while considering only one independent variable or factor. Now, if you are still confused about independent and dependent variables, then here's some explanation. Remember that the value of the independent variable is controlled by the experimenter, while the value of the dependent variable only changes in response to the independent variable. Second is repeated measures ANOVA. It is one factor with at least 2 levels, and levels are dependent. Now, for example, you might be investigating the effect of a 6-month exercise training program on blood pressure and want to measure blood pressure at 3 separate time points: pre, midway, and post-exercise intervention, which would allow you to develop a time course for any exercise effect. In this example, our independent factor would be time, and our levels would be the specific time points: time point 1, time point 2, and time point 3. Lastly, we have factorial ANOVA. This is a type of ANOVA where there are 2 or more factors, each of which with at least 2 levels. And levels can be either independent, dependent, or both. If they're both, it's called a mixed factorial design. So for example, suppose that a new drug has been developed to control hypertension. We want to test the effect of quantity of the drug taken and the effect of gender. Suppose that we consider 2 quantities, say 100 milligrams and 250 milligrams of drug, and male and female for gender. Here, our independent factors would be quantity of drug and gender, while our levels would be 100 milligrams, 250 milligrams, male and female. Here are examples of tables showing 3 different types of ANOVA. The upper left shows one-way ANOVA, the one on the upper right shows repeated measures ANOVA, and the one below obviously shows factorial ANOVA, since it has 2 variables. One is gender, men and women, and one is day 1, day 2, and day 3. So that's 2 factors. One has 2 levels and one has 3 levels. Now let's proceed to the assumptions of ANOVA. Now ANOVA has a few assumptions. We will be tackling 4. Now these 4 are normality of sampling distribution of means, independence of errors, absence of outliers, and homogeneity of means. So first, we have the normality of sampling distribution of means, meaning that the distribution of sample means is normally distributed. The core element of the assumption of normality asserts that the distribution of sample means across independent samples is normal. So in technical terms, the assumption of normality claims that the sampling distribution of the mean is normal, or that the distribution of means across samples is normal. Next, we have the independence of errors. that error between cases are independent from one another. Third is the absence of outliers. Outlier scores have to be removed from the dataset if you want to perform an ANOVA and get meaningful results. So, what is an outlier? It is a data point that differs significantly from other observations and can cause serious problems in statistical analysis. If you look at the upper right corner of this slide, you will see that the data points are close to each other except for one. That one point far from others is what you call an outlier. Lastly, we have the fourth, which is the homogeneity of variance. It states that population variances in different levels of each independent variable are equal. Now, hypotheses in ANOVA. Imagine you have one factor with 3 levels. Your null hypothesis is that all 3 levels are equal to one another. Your alternative is that not all means are equal. Now, you can't write A1 is not equal to A2 is not equal to A3 because that would mean that all 3 means are different. Maybe only 1 and 2 are different, or maybe 1 and 3 are different. So your alternative has to be written as not all means are equal. When you're dealing with the effect of one variable, it's called the main effect. But here, in the second one, imagine we have an ANOVA with 2 factors, A and B. You would have 3 different sets of hypotheses. You'd have one for A, one for B, and one for the combination or the interaction of A and B. And if you'd have 3 factors, you'd have even more things going on. So here, you have the main effect of A and the main effect of B. And you can also test for the interaction of A and B, which would be structured just like that. The null being the interaction is absent, and the alternative being that the interaction is present. So let's talk more about main effects and interaction effects. Now we have the main effects in ANOVA. Pretend we are comparing the test scores of people who have received a medication, 100 milligrams dosage group, and people who have not received a medication, 0 milligrams dosage group. The 0 milligrams condition has a mean of 60, while the 100 milligrams condition has a mean of 80. This could be represented in a graph like this. This would be a main effect. The first group has a mean of 60 and the second group has a mean of 80. This is how you can draw it in a graph. We can do it in this manner because it is a more meaningful way of showing an interaction in ANOVA. So here's an interaction. Let's say we have a factorial ANOVA with 2 factors, dosage 0 milligrams and 100 milligrams, and gender, men and women. In the 0 milligrams dosage condition, men have a mean of 60, while women have a mean of 80. In the 100 milligrams dosage condition, men have a mean of 80, while women have a mean of 50. This can be represented in a graph like this. So now the graph would look something like this. you can see that the lines for men and women cross. If the lines cross like this, that means you have an interaction effect in your ANOVA. Basically, what interaction means is that the effect at one level depends on the other level. So for example, at 0 milligrams, men are lower than women, but at 100 milligrams, men are higher than women. So the effect of gender depends on what level of dosage you're at, and the effects of dosage depends on what level of gender you're at. The variables have interacted in this way. Now we have post hoc tests. Now we have post hoc analysis. Now after you do an ANOVA, you might do something called a post hoc analysis. Because remember, if we reject the null hypothesis, all we know is that there's a difference somewhere between our groups. We don't know where that difference is, so additional tests, called post hoc tests, can be done to help determine where the differences lie. Maybe groups 1 and 2 are different, maybe 2 and 3 are different, or maybe they're all different. The post hoc test will tell us that, and there are different ones we can perform. Next, we have the F distribution. When we're doing an ANOVA, we calculate an F statistic. An F statistic is similar to other statistics such as Z and T. F test. It is any statistical test in which the test statistic has an F distribution under the null hypothesis. It is most often used when comparing statistical models that have been fitted to a dataset in order to identify the model that best fits the population from which the data were sampled. F at its most basic form, like this, treatment differences plus random differences divided by random differences. If there are no treatment differences, that is, if there is no actual effect, we might expect F to be 1. If there are treatment differences, we expect F to be greater than 1. The F statistic has its own one-tailed distribution, much like how the Z and T statistics have their own separate distributions. F is always positive, and a negative indicates that you made some mistake. So that's the end of our first discussion about ANOVA. Special thanks to our sources. And now we will proceed to the second part of this tutorial, which is the computations in ANOVA.
ANOVA and its computations. So in ANOVA, we have steps in solving. First is state the HO or null hypothesis. Second, set the level of significance. Third, complete the ANOVA table. Fourth, find the tabular value or TV. And fifth, decide. So we have example number 1. Determine who among the 3 salesmen will likely be promoted based on their monthly sales in pesos. So first, you have to state the HO or null hypothesis. Our null hypothesis would be there is no significant difference among the 3 salesmen. Next, you have to set the level of significance to 5%. Next, we will be proceeding to complete the ANOVA table. In the table, you can observe 5 columns, namely source of variation, sum of squares, degrees of freedom or DF, mean of squares, and F. You can also see SSB, SSW, TSS under the second column, K-1, which is the formula of DFT, N-K, which is the formula of DFW, and N-1, which is the formula of DFT. We also have MSD and MSW under mean of squares. And lastly, the formula of F in the last column. So here are the 3 formulas for the second column. So let's start with step 1 in completing the table. Step 1. Add 3 more columns. A square, B square, and C square. Step 2. Fill in the rest of the table by finding for their respective squares. A square, B square, and C square. Here, for example, we have the first row of A. To fill in the first row of the fourth column, we must find the square of 120. So 120 square equals to 120 times 120. Then we get the answer 14,400. And this becomes the answer of 8. Now all you have to do is to do the same for the rest of the empty cells. Once you're done, you can pause the video to check your answers, which will be given later on. So here's the guide to your answers. Now we have step 3. Find the summation of each column. Summation of A, summation of B, summation of C, summation of A squared, summation of B squared, and summation of C squared. Now for example, for the first column A, all we have to do is to add everything. After adding everything, you'll then get 1,300 that will serve as your summation of A. The same will be done for the summation of B, summation of C, summation of A squared, summation of B squared, and summation of C squared. Once you're done, you'll get these answers. Summation of B, 1,291. Summation of C, 1,285. Summation of A squared, 195,122. Summation of B squared, 189,243. And summation of C squared, 185,613. Now we have step 4. Since we have the summation of each column already, we can now proceed to filling in the ANOVA table using the formulas given and the answers of our summations earlier. So let's start with solving for SSB. All we have to do is to substitute the formula. In simpler terms, or in simpler forms, the formula can also be written like this. Summation of a squared plus summation of b squared plus summation of c squared over n sub ai minus summation of a plus summation of b plus summation of c squared over n. So to clarify things out, you can look at the color codings to serve as your guide. Now you might wonder, get confused how we got 9 or 27. So when you look at the table, to get for n sub ai, all you need to do is to count the number of rows. You have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that will be the value of your n sub ai. Now to get for the value of n, all you have to do is to count the number of given columns, excluding those you just added earlier from the first step, and multiply the value with the number of rows. So we have 1, 2, and 3 given columns. So we have n sub ai is equal to 9, while n, number of rows, multiplied by given number of columns, which is 9 multiplied by 3, which equals to 27. After substituting, get a calculator and input it and get the answer. Your answer will then be 12.67, rounded off to the second decimal place. Next, we have to solve for TSS. Just like SSB, all we need to do is substitute what's in the formula. The formula can also be written in this form. Summation of a squared plus summation of b squared plus summation of c squared minus summation of a plus summation of b plus summation of c squared over n. Now all we have to do is to substitute with the values given on the left side. You'll get the answer 13,556.67. Next, lastly, for the second column, we have to solve for SSW. Though this was supposed to be next to SSB, we solved it last because in order to get this, the formula requires the value of TSS. So here we just have to simply substitute with the answers we had lately with this given formula. So we have 13,556.67 minus 12.67. Input that in your calculator and we'll get 13,544. Next, we have to solve for the degrees of freedom. Remember that k will be 3, which is the number of given columns, and n will be 27, which is the number of rows multiplied by the given number of columns. DFB is equal to K minus 1, 3 minus 1, which equals to 2, while DFW is equal to N minus K, which is 27 minus 3, which equals to 24, while DFT is equal to N minus 1, which is 27 minus 1, is equal to 26. Now, let's proceed to the fourth column. You have to solve for the mean of squares. So MSB is equal to SSB over DFB, and MSW is equal to SSW over DFW. So let's proceed first with MSB. All we have to do is to simply substitute. So MSB is equal to 12.67 over 2. When you input that in your calculator, you'll get 6.34. While in MSW, we have SSW over DFW, and we have, when we substitute that, 13,544 over 24. Input that in your calculator and you'll get 564.33. For the last part, we have solved for the F. So F just requires the answers of MSB and MSW. So we have F is equal to MSB over MSW. So when you substitute it, F equals to 6.34 over 564.33. Input that in your calculator and you'll get 0.01. This will serve as your computed value. And in the table, it must be written as this, where 2 is your DFB and 24 is your DFW. Now, the table should look like this after you have solved for everything. You can check your answers, pause the video. Now, after you've checked your answers, let's go to the next part. So in the next part, we have to find the tabular value. All we need to do is to use the F distribution tables and the values of DFB and DFW to find out the TV. Remember that the significance is usually stated when you're given the set, but if not, then automatically use 5%. So here we have the table of the F distribution with a 5% level of significance. We have the F distribution with a 1% level of significance. Now for this example, we have to look at the 5% table. Simply look at the columns and rows where DFB will represent what column to look at, while DFW will represent what row to look at. Now just find the cross-section of the values and you'll get 3.40 and round it off to the second decimal to make it simpler. Next is the decision making. Here we make use of the statements CV is greater than TV or CV is lesser than TV. So of course 0.01 is lesser than 3.40. So we have the answer CV is lesser than TV. And remember the acronyms LA and HR. If you use the statement lesser than, where CV is lower or lesser than TV, then accept the null hypothesis. And if you use the statement greater than, where CV is higher than TV, then reject the null hypothesis. So we have lower accept, higher reject. And your decision will be the HO is accepted because CV is lesser than TV. There is no significant difference among the three salesmen. So here we have example number 2. Determine who will be granted a scholarship based on academic performance and kind of schools attended. In this example, the schools will be your variables. So again, first we have to state the HO or null hypothesis. Your null hypothesis will be there is no significant difference among the academic performance and the kind of schools attended. Next, we have to set the level of significance to 5%. Note that this must always be done in cases where the level of significance is not specified. Next, we will proceed to completing the ANOVA table. So as said earlier, these are the formulas. And to serve as your guide, to the right is the legend of what the letters mean. So let's proceed to step 1 in completing the table. Step 1, add 4 more rows. A square, B square, C square, and D square. So why did we add 4 more rows instead of 4 more columns? Because as said earlier, your columns or schools are your variables. So step 2, fill in the rest of the table by finding for their respective squares. So we have the example for Sci-High 8.8. So first we have to get the square of 8.8. So 8.8 squared is equal to 8.8 times 8.8. And then you'll get 77.44. Now all you have to do is do the same for the remaining cells. Pause the video if you want to catch up or if you want to check your answers. Next, step 3, we have to find the summation of each row. So here's an example for the first row, A. You have to sum up all the numbers. Upon the summing up of all the numbers of each row, we'll get summation of A is equal to 61.5, summation of B equals to 61.3, summation of C equals to 60.7, summation of D equals to 60.8, summation of a squared is equal to 540.55. Summation of b squared is equal to 537.97. Summation of c squared is equal to 528.77. And summation c squared is equal to 531.54. Now, since we have the summation of each column already, we can now proceed to filling in the ANOVA table using the formulas given. So first, we have to solve for SSB. In order to solve for SSB, we should use this formula, or the expanded form, if you get confused. And then all we need to do is to substitute.
Now you might wonder how we got the number 7 and the number 28 in the formula.
So to get n sub ai, we have to count the number of columns instead of the number of rows. So number of columns, we have 1, 2, 3, 4, 5, 6, 7. While to get n, we have the number of columns multiplied by the number of given rows. So the given rows are 1, 2, 3, and 4. 4 given rows. So therefore, we have n sub ai is equal to 7, and n is equal to 7 times 4, which is equal to 28. So here, once you input the substitutions in your calculator, you'll get the answer 0.06, rounded off to the second decimal place. Next, we have to solve for the TSS. So TSS, this will be your given formula, or the expanded form. And again, you have to substitute. You have to input that in your calculator, and you'll get the answer 7.31. Next, we have to solve for SSW. Given the formula, TSS minus SSB. Next, we have to substitute, which was the given two answers we solved earlier, and you'll get 7.25. So next, we have to solve for the degrees of freedom. We have DFB, DFW, and DFT. DFB is equal to k minus 1. DFB is equal to 4 minus 1, which is 3. Next, we have DFW. DFW is equal to n minus k, which is equal to 28 minus 4, and you'll get the answer 24. Next, we have DFT, which is n minus 1. Substitute it, and you'll have 28 minus 1, which is equal to 27. Next, we have to solve for the mean of squares. MSB is equal to SSB over DFB, which is equal to 0.06 over 3, and you'll get the answer 0.02. Next, we have MSW equals to SSW over DFW. So MSW is equal to 7.25, over 24, and you'll get the answer 0.3. So next we have to solve for f, which is MSB over MSW. So we have 2.02 over 0.3, which is equal to 0.07, and should be written in the table as 3, 24 is equal to 0.07, where 3 is your DFB and 24 is your DFW, while your computed value will be 0.07. Now your table should look like this. You can pause the video to check if your answers are the same. So the next part we have to find for the tabular value, or TV. All we need to do is to use the F distribution tables and the values of DFB and DFW to find out the TV. Remember that the level of significance is usually stated when you're given the set, but if not, then automatically use 5%. So here is an example of the F distribution table again, just 5%. Here we have an example of the 1% level of significance of the F distribution table. So here, for this example, we have to look at the 5% table. Simply look at the columns and rows where DFB will represent what column to look at, while DFW will represent what row to look at. And just find the cross-section of both. And we'll get the value . Again, you can round it off to the second decimal place to make it simpler. Decision making. So we have to use the statements CV is greater than or CV is lesser than TV. So of course 0.07 is lesser than 3.01. So answer, CV is lesser than TV. And remember the acronyms LA and HR. Lower accept, higher reject. And now your decision will be the HO is accepted because CV is lesser than TV. There is no significant difference among the academic performance any kind of schools attended.
Now, we have example number 3. So let's have the example. Determine which of the 3 stores give the best customer service based on the ratings of buyers. So first, we have to state the null hypothesis. The null hypothesis says that there is no significant difference among the 3 stores. Next is we have to set the level of significance to 5%. Note that this must always be done in cases where the level of significance is not specified. Next, we will proceed to completing the ANOVA table. In the table, you can observe 5 columns, namely source of variation, sum of squares, degrees of freedom or the DF, mean of squares, and F. You can also see SSB, SSW, TSS under the second column. K minus 1, which is the formula of DFB, N minus K, which is the formula of DFW, and N minus 1, which is the formula of DFT. We also have MSB and MSW under mean of squares, and lastly, the formula of F in the last column. To the right, you can see what the letters in the formula stand for. A, which is the given factor, I for individual observation, N for sample, K for number of columns, and X for observed values. So let's start with step 1 in completing the table. Step 1. Add 3 more columns. Step 2. Fill in the rest of the table by finding for the respective squares.
So here, for example, we have A. So we have 8. We have to get the square of 8. 8 squared is equal to 8 times 8, which is equal to 64. As simple as that. Now all we have to do now is to fill in the rest of the table by finding for their respective squares. You can pause the video to see if your answers are correct. Now step 3. We need to find the summation of each column. For example, we have column A. All we have to do is to sum up the numbers all the way down. So here we'll get the answer, summation of A is equal to 56. And now we have to do the same for summation of B, summation of C, summation of A squared, summation of B squared, and summation of C squared. And you'll get the answers 38, 29, 458, 212, and 131. Now since we have the summation of each column already, we can now proceed to filling in the ANOVA table using the formulas given. So now we have to solve for SSB. Given this formula, or the expanded form, all we need to do is to substitute it with the summations we did earlier. Now this will be your substituted form. If you get confused, here are color codings.
Now you might get confused where we got 7 and where we got the other one, 21, in the formula given.
So we have an explanation for how we got 7 and 21. So we have n sub ai, which is shown in the formula. We can get this by counting the number of rows, which is 1, 2, 3, 4, 5, 6, 7. While n will be the number of rows, which is 7 multiplied by the given number of columns, excluding the ones you've just added, which is A, B, and C. And here you'll get 7 for n sub ai, and for n, 7 times 3, 21. Again, input that in your calculator, and you'll get 54, which is rounded off to the second decimal place. Next, we have to solve for TSS, given this formula or the expanded form. Substitute it, and you'll get these values. Input it in your calculator, and you'll get 80.57. Next, we have to solve for SSW, which will use the answers you got earlier, TSS and SSV. So SSW is equal to 80.57 minus 54, which will equal to 26.57. Next, we have to solve for the degrees of freedom, or DF. So DFB is equal to k minus 1, which is equal to 3 minus 1, and you'll get the answer 2. DFW, n minus k, then 21 minus 3, and you'll get the answer 18. While DFT, we have n minus 1, then 21 minus 1, and you'll get the answer 20. Next, we have to solve for the mean of squares. MSB is equal to SSB over DFB. Substitute it, you'll get 54 over 2, and the answer 27. While MSW is equal to SSW over DFW. Substitute it, and you'll get 26.57 over 18. Then the answer 1.48. And lastly, in the last column, we have to solve for F, which is MSB over MSW. Substitute it, you'll get 27 over 1.48, and the answer 18.24. which will be written in the table as 2, 18 equals to 18.24, where 2 is your DFB and 18 is your DFW. And 18.24 will be your computed value. Now your table will then look like this. You can pause the video to see if all your answers are correct. Next part, we have to find for the tabular value or TV. All we need to do is to use the F distribution tables and the values of DFB and DFW to find out the TV. Remember that the significance is usually stated when you're given the set, but if not, then automatically use 5. So here's an example of an F distribution table with 5% level of significance.
And here we have a table, the F distribution with a 1% level of significance.
For this example, you have to look at the 5% table in order to get TV. Simply look at the columns and rows where DFB will represent what column to look at and DFW will represent what row to look at. And just find the cross-section of both.
And you'll get 3.55. You can round it off to the second decimal place to make it simpler.
Next is the decision making. Here we make use of the statements CV is greater than TV or CV is lesser than TV. So of course 18.24 is higher or greater than TV, which is 3.55. So your answer will be CV is greater than TV. And remember the acronym LA and HR. Lower accept, higher reject. So then comes your decision, which is HO is rejected because CV is greater than TV. There is a significant difference among the 3 stores.
So that would be all. We hope you understand our discussion and maths of our video tutorial about ANOVA. Please like and subscribe to our channel. Thank you. This is brought to you by Angela Nia Lim, Carla Sebastian Bersabal, and Fatima Kiao of 10 Emerald. God bless.